Hello YouTube. I want to make a video on binary search. I came across this problem on LeetCode and I was having some trouble trying to figure it out. And I looked up YouTube videos and stuff, but they were using for loops and other methods that I didn't really understand. So I kind of made it similar to the way I did merge sort. I kind of thought of it like the same way, where we're splitting the array in half until we find the current index. And I did this recursively, but let me just show a quick example of what binary search is. Binary search is we're going to have an array, 7, just an array, and we're going to be splitting the array into halves and then splitting those halves into halves until we find our target. So for this example, let's just say our target is equal to 6. We would split 7, and this is the way I did it, so I'm doing step by step in the way I did it, the way I thought of it. So sorry, 7 divided by 2 is 3 because it's 3.5, but it rounds down. So our middle would be 0, 1, 2, 3, 4. Then we will check our target and compare it to our middle. In this case, 6 is greater than 4, which is our middle. So we're going to just capture this part of the array. 5, 6, 7. We don't even need to check back here because we already know that it's not going to be there. And because it's sorted, it's not going to be back there, right? So now t is equal to 6 still. And then we now divide this array into half. So we say 3 divided by 2, divided by 2 is equal to what? 1. It's 1.5, but we round down like I said before. Middle is equal to 0, 1, 6. 6 is equal to 6. So we found our element, and then what we would do is we would count up where we divided the numbers. So we would have 1, 3. So it would be our current index, which is 1, plus our previous middles, which is 1 plus 3, which is equal to 5. And then we check right here, 0, 1, 2, 3, 4, 5. The fifth index there is 6. So essentially this is what my code is doing. And now let's go into it. So we're going to include vector, and then we're going to say int binary. Can I type? Int binary search, and this function is going to take in 2 parameters. std a vector first off, vector int, and I'm just going to call it array, and then int target as well. Okay, so once we have this down, we want to check if the array that we inputted is empty or not. So we say if, sorry, not int, if array dot empty, just return -1. We return -1 because this is not in bounds of this array. There is no -1 index, so it means it's false. It means there's nothing there essentially. So we have this down for if it's empty, if we pass in an empty array. Now we want to check if the index is actually in the middle or not in our first run. So if target is equal to array at middle. Oh, sorry, we haven't even created the middle yet. Int middle, we want to create a middle, which is equal to the array dot size divided by 2. And this middle will continuously change, as I showed right here before. Oh shoot. Yeah, it's going to change after each run because we're using recursion. So yeah, so after each pass, when we pass in the left and the right array, depending on where our target is, based on the based on like where it is in the index is what I'm trying to say. Sorry, we're going to pass in either the left or the left or the right part of the array. So if target is equal to middle, we just want to return the middle. Return middle. Shoot. And then now we want to check if the target is greater than the middle. So we say if target is greater than the array at middle. So the element at the middle array, at the middle index, sorry. Wrong brackets. Then we want to create the right array because it's going to be on the right side of the array. So std vector int right array, and then now we're going to pass in from the array dot beginning. We want it to be the length of array dot beginning plus middle, and then here we're going to say +1 because we do not want to include the actual middle element because we already checked it. It's not it's never going to be the middle element if target is greater than the middle element. So we don't even need in this example we don't even need the 4. So we say +1 array dot beginning to the middle, which is here +1. So just include from 5, 6, 7 till array dot end. And then we're going to create a result to hold the current indexes. So we're going to say result int result is equal to, and then this is where we do the recursive call, binary search. We call it binary search on the right array, and we want to keep the same target. And here we say if result does not equal -1, so meaning that if result is a valid number, so yeah, if result is a valid number within the array, we want to return the result plus the middle plus 1. And I will be explaining what exactly this does in just a sec. I can just do it real quick right here. Like I said before, this would have been our right array here as we pass it in. We do our calculations. 3 divided by 2 is 1. Middle is our middle element, I should say middle element our middle element is 6. Then we do 6 is equal to 6, and here we would return, since 6 is in this array, 6 is at index 0, 1, we would return the result, which is index 1 plus our previous middle, and then since it's a recursive call, we do plus our other middle as well. Plus, I did this backwards. Hold up. Sorry. It should be like this. 3 plus 1. So we do our current index. Our current index, which is 1, plus our first middle, which is 3, plus adjusting for the index plus 1, we get 5. So 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Yeah, 6. So we got that if it's on the right side. Else, if target is less than the array at middle, we want to create a left vector now. Int which is going to be from array dot begin until array dot begin plus middle. Here we just say plus middle because if say for example our target was 3, we want to keep on including the middle element just so we can compare and check it, right? So, and same with the right array now. We're going to say if result, if result does not equal -1, meaning that if I haven't even created a result. So int result actually is equal to binary search. Then we call left vector. I should change this to array, sorry. Keep some consistency, right? Array. And then we keep the target. So int result is equal to binary search, so call in binary search on the left array and keep the target, same target. So if result is a valid entry within the array, we just return the result. We don't have to do anything. And here we're going to return, if none of this ends up being true, we just want to return -1, meaning that the element was not found in the array. So here we're going to say, let's test it out, std vector int array, just call it array, is equal to, let's see, 7. 1, 2, 3, 4, 5, 6, 7. So how I had in my previous example. And then we're going to say std cout target is at array. And then we're going to call in binary search on array. And our target, what did I have my target as? 6 in this example. 6. And then if we run it, target is at array 5. What did I say? Array 5 up here. 0, 1, 2, 3, 4, 5. Now if we do 7, it should say 6. Yes, it does. Let's put in some more numbers. 8, 9, 10, 11. Let's test 2 as our target. 0, 0, 1, that works. Let's test 4. Target 4, 0, 1, 2, 3. As you can see, it works. So it kind of took me a while to fully understand how. Sorry, I got cut off on my last video. I tried recording on this screen, trying to do a dual screen to show the code, and while I was drawing at the same time, but for some reason it cut off. I'm not very good at these videos, but what I was trying to say is that it took me a while for me to understand fully what was going on with this code, but I did so by step by step. Writing it down and seeing what it did, and I just want to show you how exactly it's working. So I believe, I forget what target, I think T was 6. So in this, based on the code, I'm just going to do step by step of what exactly is happening. We do the length of the array, so 7 divided by 2. So length divided by 2, we get the middle element. This is 3.5, but we ran down to 3. Oh, what an ugly 3. 3. So this is equal to middle. I'm going to say middle, and then ME. Oh, geez. ME middle element is equal to 0, 1, 2, 3, 4. So in my code, we had if the target is greater than, we check if it's first. We check the greater than first, and then we do the less than if the target is less than the middle element second. In this case, we would go into the first if statement based on this, because 6 is in fact greater than 4, which is the middle element. And in the code, we would call binary search on, I'm going to say BS on the, what was it? Binary search on the array from the beginning. So array dot b, I'm going to say beginning plus the middle element, so plus middle, m, so 1, 0, 1, 2, 3, plus 1, because we don't want to include the current middle element till the end. Sorry, this says end right here. I'm sorry for the horrible handwriting. So we'd call binary search on this part of the array. So let me get rid of all of this real quick. Sorry. So now we would call binary search on 5, 6, and 7. Do the same thing how we have here. Target is still 6, so it would be 3. Oh my lord. 3 divided by 2, which is 1.5. In this case, we round down to 1. 0, 1, this is our index right here. So 6 is equal to 6. We found the element. And since it was part of the right array, so the first if statement, the right, the larger part, we would return the result, which is 1 right now, which is our current index in this array. So 1 plus the middle of our previous recursive call, 1 plus 3 plus, and then if you remember we said plus 1 to account for the change of index, which is equal to 5. 0, 1, 2, 3, 4, 5. Fifth index is where we find number 6. Now if we do it for a smaller number, so let's try it out with the same array. So t is equal to 2 in this case. Let me erase this box, sorry. Okay, t is equal to 2 now. Again, we would do 7 divided by 2, which is going to give us 3. E, middle element is equal to 4. We check if 2 is greater than or less than 4. In this case, we would skip the first if statement because obviously 2 is less than 4. So 2 is less than 4. Now we would check from array.begin till array.begin plus middle, so from 1 to 4. 1, 2, 3, 4. So 1, 2, 3, 4. 4. Now we do this. Remember that we passed in binary search on. We do recursive call, so we pass. This is the left array, so we say binary search left array with the same target. Now we do 4 divided by 2, which is equal to 2. So this is m middle element is equal to 0, 1, 2. Oh my lord, this is horrible. Middle element is equal to 0, 1, 2, 3. Check if 2 is less than or greater than the middle. In this case, 2 is obviously less than 3. Recursive call from beginning till the middle again. So now we just do 1, 2, 3. Middle is equal to 3 divided by 2, which is equal to 1.5, or in this case 1. Middle element is equal to 0, 1, 2. And in this case, since it was part of the left array, we just return, if you go back to my code, it just says return result. If we return the result, this is result right here. This 1 is the result, which is the index. 0, 1, here is 2. We found 2. So essentially this is what's going on with the code step by step, exactly how it's moving and stuff. I hope y'all enjoyed, and I hope y'all learned something from me. Thank y'all for watching. Bye bye.